Hello everyone, I welcome you all to my YouTube channel Ankuram. In today's lecture, we are going to see about discrete Fourier transform. I am Aishwarya, Assistant Professor, EC Department, working at RMK College of Engineering and Technology. This is the general outline of today's presentation. First, I will introduce what is discrete Fourier transform. Then, the relationship between DTFT and DFT will be narrated. Then, I will solve some sample problems on how to compute DFT and IDFT. I will also say a simple way on how to compute DFT and IDFT using calculator. So first, what is DFT? DFT refers to discrete Fourier transform. What is the working principle or what does DFT will do? It will convert the continuous function of omega to a discrete function of omega. What is omega? Omega is nothing but the angular frequency and the range will be from 0 to 2 pi. Where I can obtain this continuous function of omega? I will obtain this from DTFT. DTFT refers to discrete time Fourier transform. So, DFT will convert the output of DTFT to a discrete function of omega. Why this conversion is necessary? Because we have to realize everything practically in a digital system. So for a digital system, we have only finite memory. However, the output here is a continuous function of omega, which means I will have infinite set of frequency components. So that is not practically realizable in a digital system. So we are going to use DFT where the output is the discrete function of frequency. The input and output of DFT is a discrete periodic signal. Okay. So this is what is discrete Fourier transform. Now I will define what is DFT and IDFT mathematically. So, the endpoint DFT for the given sequence x of n, it is defined as x of k, where k refers to the frequency component, which is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi by n into nk, where the k varies from 0 to n minus 1. This is the formula for endpoint DFT. Now, I can say the endpoint DFT equation as analysis equation. This formula is applicable only when n is greater than or equal to L. N is the endpoint DFT and L refers to the length of the sequence x of n. Okay. So, we have to satisfy this condition before applying the DFT formula. Otherwise, I will have time aliasing effect. In order to avoid that, we are going to use this condition n greater than or equal to L. Next, the IDFT for the sequence x of k, or I can obtain the time domain sequence x of n given my x of k as x of n equal to 1 by n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n into nk, where your n varies from 0 to n minus 1. This equation is called as synthesis equation. The equation 1 and the equation 2 are called as DFT pair. Okay. Now, I will go to the frequency domain sampling of DTFT. I can say when I sample the DTFT in the frequency domain, I will get something called as DFT. So, let me narrate the principle. For example, we know the formula for DTFT as x of omega. This is the formula for DTFT. Okay. So, the x of omega is equal to summation n equal to minus infinity to infinity x of n e power minus j omega n. This is the formula for DTFT. Now, this is a continuous function of omega where the omega ranges from 0 to 2 pi. Now, what I need? I need the discrete function of omega, which is nothing but your DFT, correct? So, how can I obtain the continuous function from, how can I obtain the discrete function from continuous function? By a process called sampling. This was already told in the first lecture. So, how can I do sampling? I can take few samples from the maximum range, that is nothing but omega. So, I am going to define my omega, which is equal to 2 pi, the maximum range, by n, only finite samples, into k, where k refers to index of each sample. Okay. Now, when I substitute, say, let me name this as equation 1. When I substitute in equation 1, what happens? It is x of 2 pi by n into k, which is equal to summation x of n e power minus j 2 pi by n into nk. What is this formula? This is the formula for your DFT. So, the frequency domain sampling of DTFT is called as DFT. And in order to compute your DFT, the main condition is that the input signal x of n has to be periodic. This is the main point. Suppose if I apply an aperiodic signal, then your x of n has to be converted to the periodic signal. That is, I have to repeat the signal to n period. Then I have to compute your DFT. This is the very important thing when you are going to compute or when you are going to find the frequency components while applying DFT. So, with this basic introduction, now I will go on how to compute DFT for a given sequence. Now, this is the problem. Compute 2-point DFT sequence for the sequence x of n, which is equal to 1, 1. Now, the first step what I have to do is, you have to check the length of the sample as well as the endpoint DFT in the question. In this case, x of n length is 2 because I have only 2 samples, and as well as my endpoint is also equal to 2. So, the length gets matched. So, you can go to the computation of DFT. Suppose if there is a mismatch in the length, say for example, my x of n is equal to 1. Okay. Now, here the length is L equal to 1. However, I have to compute for 2-point DFT. Then, in order to match the length, what I have to do? You have to pad additional zeros in order to get a perfect match. In this case, I will pad only 1 0. So, it will be x of n 1, x of n equal to 1, 0. So, the length gets matched. Then, you can compute the problem. So, coming back to our problem, we don't have any issues in the length. So, we can directly proceed with the formula. So, why we are padding zeros? We are padding zeros in order to get better spectral coefficients. In order to view your spectra efficiently, we are padding zeros. However, it is not going to convey any information in the frequency domain. Okay. So, this is what is step 2. So, step 2, I have to compute DFT. We know the formula for DFT as x of k, which is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi by n into nk, where k varies from 0 to n minus 1. Now what is n in the question? N equal to 2. Okay. Now when you are substituting in this formula, it is x of k, which is equal to summation n equal to 0 to 1 x of n e power minus j. When you substitute n as 2, 2 gets cancelled. So it is e power minus j pi n k, where k varies from 0 to 1. Okay. Now you expand the summation. Substitute for n equal to 0. So it is x of 0, e power 0 is 1 plus x of 1. When you substitute here, it is e power minus j pi k. This is what is your x of k for k varies from 0 to 1. Okay, va? Now we will compute the coefficient for every value of k. Okay. Now when you substitute k as 0, what will happen to the equation? X of 0, which is equal to x of 0 plus x of 1 into e power minus j pi k is the equation. So it will become x of 0 is the question. So it is 1, correct? So this is what is your x of 0 and this is your x of 1. Okay. So x of 0 is 1 plus 1 e power minus j pi k. Now k is 0. So which is equal to 1 plus e power 0 is 1. So it is 1. So the sample is 2. So x of 0 is 2. Now you substitute for k equal to 1. I will get x of 1, which is equal to x of 0, which is nothing but 1 plus 1 e power minus j pi k. So it is e power minus j pi. So when you expand, it is 1 plus cos pi minus j sin pi. Correct? Because e power minus j theta is equal to cos theta minus j sin theta. Instead of theta, in this question we have pi. So it is equal to 1 plus, what is cos pi? It is minus 1. Similarly, sin pi is 0. Okay, so it is 1 minus 1, so it is 0. So finally, when I write my x of k, which is equal to, for k equal to 0, it is 2, and for k equal to 1, it is 0. This is my final DFT, 2-point DFT sequence for the given x of n. Okay. Now this is a very simple computation. Now when we go for higher order n-point sequence, say for example, I am going to compute the 4-point DFT sequence for the given samples. Okay. Now my x of n in this question is equal to 1, 2, 3, 4. What is the first step? Always I should check the length of n and length of L. So in this question, the length of the given sequence x of n is equal to 4 and I have to compute 4-point sequence. So both lengths gets matched up. So we can directly substitute the formula. So substitute the formula. So what is the formula for n-point DFT? X of k, which is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi by n into nk, where k varies from 0 to n minus 1. Okay. Now which is equal to summation n equal to 0 to n minus 1 is 3 x of n. When you substitute 4, it is e power minus j pi by 2 into nk, where k varies from 0 to 3. Correct? Now you expand the summation. It is x of 0. When you substitute e power 0, it is 1 plus x of 1 into e power minus j pi by 2k plus x of 2. When you substitute n as 2, it is e power minus j pi k plus x of 3 into e power minus j pi by 2. When you substitute n as 3, it is 3 pi k. So, this is your x of k. Now, you substitute the samples x of 0, x of 1, x of 2 and x of 3. When you substitute the samples, what happens? So, when you substitute the samples, x of k is equal to x of 0 is 1 plus 2 into e power minus j pi k by 2 plus 3 into e power minus j pi k plus 4 into e power minus j 3 pi k by 2 for k equal to 0 to 3. Okay. Now, you want to find x of k for different values. So, before that, we can expand this e power j terms in terms of cos and sine. Then I will say how to compute this long sequence using calculator. So, before that, first I will expand 1 plus 2 into, when I expand e power minus j theta, instead of theta I have pi k by 2. So, it is cos pi k by 2 minus j sine pi k by 2. Correct? Plus 3 into, when you expand the second e power j term, it is cos pi k minus j sine pi k plus 4 into, here I have cos 3 pi k by 2 minus j sine 3 pi k by 2. Now, you have to find for different values of k. So, once this is done, I will say how to compute this long sequence in fraction of seconds using your calculator. Which means I have to find x of 0, I have to find x of 1, I have to do x of 2 and x of 3. Correct? So, before computing all these things in the calculator, you have to keep your calculator in radians mode, as well as you have to keep it in complex mode. These things are very, very important before doing the computations. Okay. So, once you have fixed this mode, now I will play a video on how to compute DFT using calculator. Let's watch the video. Now you listen. I have kept my calculator in radians mode and complex mode. So, this is my x of k sequence. This I am going to type in my calculator. The bracket should be enclosed very properly. See here. So, it has been enclosed like this and I am typing in a similar fashion. So, instead of k, I can use alpha button in the calculator. So, I can use A, B, C, D, E, F. See here, A, B, C, D, E, F. I have the variables. So, instead of k, I am using A as a variable. So, it is cos pi a by 2 minus j sine. Instead of j, I will use I. So, I is here. I sine, open the braces, pi a divided by 2. Okay. The first term is over. Always you should enclose the angles in the brackets also. Don't forget this. Plus, type the second term, cos pi instead of k a plus I sine pi a. So, I have completed the third term. Then you have to type the fourth term. 4 open the bracket, cos 3 pi a divided by 2 minus I sin 3 pi a divided by 2. So I have typed all the terms now. Now what I have to do is, I have to compute for every value of k, correct? Which means I have to compute for 0, 1, 2, 3. For that I have to use the button CALC. Okay. So first, what is the value of a? It is 0, correct? So the real part is 10. So you write x of k at k equal to 0 will be 10 for the real thing, and for the imaginary you have to press shift equal to button. Okay. Now you check here, you don't have any imaginary, it is 0 I, correct? So you have only real part, so it is 10. Now I have to compute for k equal to 1, that is a equal to 1. So when I compute a equal to 1, the real part is minus 2, correct? Plus your imaginary. Imaginary is 2i. Okay. So it is plus 2i. Similarly, compute for k equal to 2. Again, press the calculation button for k equal to 2, which will be minus 2 for your real part, and the imaginary is 0i. So I am not writing that. Similarly, compute for k equal to 3. The real part is minus 2. Check for the imaginary. It is minus 2i. Okay. So I have computed for all the k values. Write the final answer. It is 10, minus 2 plus 2i, or j, minus 2, minus 2 minus 2j. Okay. This is what is the final DFT sequence for the given question x of n. Now we will compute on how to compute IDFT for the given x of k sequence. Now you count the very first step. What I have to do? The same fashion, except that you have to change the formula alone. Step 1. First count the samples. 1, 2, 3, 4, 5, 6, 7, 8. So I have to compute for n equal to 8, the maximum number. And also the length L, here it is given as 8. So both are same. So I can start with my 8-point IDFT. This is what is step 2. So what is the formula for IDFT? X of n, which is equal to 1 by n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n into nk, where your n varies from 0 to n minus 1. So it is 1 by n is 8 here. So 1 by 8, open the bracket. So 1 by 8. Now you substitute the value of k for every value. So k varies from 0 to 7, correct? So it is x of 0 plus x of 1 e power j 2 pi by n. So here it is e power j pi by 4 nk. Okay, when I substitute n as 8 here. Okay, so x of 1 e power j pi, when I substitute k as 1, it is pi n by 4 plus x of 2, when I substitute n as 2 here, when I substitute k as 2, it is e power j pi n by 2 plus x of 3 e power j 3 pi n by 4 plus x of 4 e power j pi n plus x of 5 into e power j 5 pi n by 4 plus x of 6 into e power j 3 pi n by 2 plus x of 7 into e power j 7 pi n by 4. Correct? This is for k n varies from 0 to 7. Correct? Now what I have to do? So before substituting for every value of n, I have to first expand the summation. Then you have to compute the values. You substitute your x of 0, x of 1 from the question. So when you substitute your x of 0, x of 1, so what happens? The final equation x of n, it will be equal to 1 by 8, x of 0 is 5 plus x of 1 is 0, so you can neglect that term. So x of 2 is 1 minus j. So it is 1 minus j e power j pi n by 2 plus again x of 3, it is 0. So you can go for the next term. So it is simply 1 into e power j pi n plus next term is again 0. So you can substitute for x of 6. So it is 1 plus j into e power j 3 pi n by 2 plus for the next term x of 7, it is 0. So you can leave till here. Okay. This is for n equal to 0 to 7. Now first expand your e power j term. 1 by 8, 5 plus 1 minus j. So e power j theta, already I told you, it is cos pi n by 2 plus, because it is e power plus j theta, plus j sin pi n by 2 plus e power j pi n. So cos pi n plus j sin pi n plus 1 plus j cos 3 pi n by 2 plus j sin 3 pi n by 2. Correct? So this is for n equal to 0 to 7. Now this will be very tedious when you are computing for every value of n. For that, what you can do? You can use your calculator to compute, which I have told you for DFT problem. So keep your calculator in radians mode as well as in complex mode before proceeding. Okay. So you type all the terms and in a similar fashion which I have told you, you have to compute for n equal to 0 to 7. Okay. So when you compute using your calculator, you will get the answer. Finally, you have to, the answer is 1, 0.75, 0.5, 0.25, 1, 0.75, 0.5 and 0.25. This is the answer. So try to use your calculator in order to substitute all the values to get your resultant x of n. Since this was already taught for you on how to use calculator for computation, I have not repeated the step. So please try and post your comments in the chat box. Thank you so much for your patient listening. Stay safe, stay connected.